Okay, we'll do question number 13. So they did not give the diagram in the question, so we'll have to draw the diagram. Okay, so let's read the question first. D and E are points on sides CA and CB respectively of a triangle ABC right angled at C. So we need a right angle triangle where the 90 degrees at C. Okay, so let's draw the 90 degree right angle triangle first. Okay, so we have right angle triangle right angled at C, so this should be C, and then AB doesn't matter, so AB. Now they're saying D is a point on CA. CA ko diya hai. On CA there is D, and then E is a point on CB, so E is a point here. So we have to prove AE. So this is A, this is E, so we need to join this. AE square. Let's join it writing. Okay. BD square. BD is here. So we can distinguish. BD square equal to AB square. AB is here, the long one, plus DE. So DE is this one. And we know that this is 90. So if we look here, we have a few right angle triangles. So before we do all of this, let's just use Pythagoras theorem and write all the triangles where we can apply Pythagoras theorem. Let's apply it and just write it here. Okay, see, for all the questions or any questions which has this kind of a thing, which most of you will not understand what's going on, the first thing you have to do is just write down the Pythagoras theorem of all the right angle triangles that is given in the question. Okay, so let's start with the smaller one. DE square equal to CD square plus CE square. Na? We have to write triangle also. In triangle DCE E by Pythagoras theorem. Okay, now let's make this equation 1. We'll do for all the triangles wherever we see. In triangle, let's do the big one, ACB by Pythagoras theorem. We can say AB square equal to AC square plus BC square. Let's make this equation 2. Now again, in triangle, we'll take this, okay, the red one. This will become the hypotenuse now. So DCB by Pythagoras theorem, we can say BD square equal to CD square plus BC square. Right? It will a triangle divided by. So this is the hypotenuse, this square, this square. Now we can take this one also. So let's make this equation number 3. In triangle, since we took BD as a hypotenuse, now we can take AE as a hypotenuse now. So AEC in triangle ACE by using Pythagoras theorem, we can say AE square equal to AC square plus CE square. Equation number 4. Is there any other right angle triangle or not? No, nah. Sorry, wait. From here we took this one first, DCE to chutawala, and then we took the bigger one, that is ABC, and then we took this one, DBC, which is this one, and then at last we took this one, ACE, which is this one. Okay, so all of these are right angle triangles, and I don't think we have any more right angle triangles to do. So now that we're done, see, this is what you're going to do for all the questions. Just write the Pythagoras theorem for all the right angles possible, and then you're going to think about what we can do now. So we have to prove AE square plus BD square equal to this by this. So to prove AE square plus BD square equal to AB square plus DE square. Now let's take LHS, left hand side. Okay, AE square plus BD square. So let's see AE. AE is here, right? So this AE information we can keep. So instead of AE, I can put AC square plus CE square. So AE is equal to this. So instead of AE, I'm putting this. Okay, instead of AE. You don't have to do the underlying part. Okay, it's just for understanding. And then we have BD equal to this also. So instead of BD, I can write what? CD square plus BC square. Instead of BD, I can write CD square plus BC square, right? Now, if I rearrange this, okay, because as I can see, I can clearly see that, see, this is AC square and then CE square and CD and BC. But if I combine AC and BC, AC square and BC square, if I combine AC square and BC square, we get AB square. And then if we combine CE and CD, we get DE. Got it? So that's what we're going to do. So we're going to rearrange. So AC square plus BC square plus CE square plus CD square. So CD plus BC, CD or AC plus BC, AC plus BC is AB, right? So we need to write reasons also from equation number 2, 3 and 4. And now this will become AC plus BC becomes AB square, and then CE square plus CD square becomes DE square, D is 0. So this is for understanding, okay? So don't write, becomes this, don't draw, I mean the underlining part. These two becomes this. So we can write from equation number 1 and 2. Got it? And then just to finish it off, we can write hence LHS equal to RHS, because LHS was this, RHS this, now we got the RHS. Got it? So last with the LHS equal to RHS लिखिदिन्छु काफी है. So here it is. So first we just write everything down, and then we use according to what we need. LHS take solve it, or even you can even do this. Okay, you stop here and then do the RHS and put the values. You'll get exactly the same. Okay, you can take LHS and then stop and do RHS. Same thing only. Okay, now that's done. Let's go to the next question, which is a little complicated. Okay, so you have to listen very carefully. Question number 14. So we will start doing the same exact thing what we did here. So let's read let's read the question. The perpendicular from A on side BC. So from A, BC, we're drawing 90 degree. Intersects BC. So A is not a 90 degree. Let me get that straight. A is not a 90 degree. It's not given. So only D is 90 degree. Such that this is the main information they have given us. BD equal to 3 times CD. Okay, let's keep that in mind. We have to prove this. Yes. So let's write by given, because that is important. BD or DB, same thing, equal to 3 times CD. Okay. Now let's use Pythagoras theorem in. We have only 2 triangles where we can apply Pythagoras theorem, so we'll just apply it. In triangle ABC, by Pythagoras theorem, we can say AC square equal to AD square plus CD square. Nah? Let's give this equation 1. Now, in triangle ADB, this triangle, okay, now, by Pythagoras theorem, we can say AB square equal to AD square plus BD square. Okay, so now the thing they've given us is this, right? This. So we can replace, whenever you see BD, we'll just replace it with 3 times CD, because I guess like so that's the reason they want us to do it. So try to convert everything into CD. That's literally what they're saying. Okay, BD equal to 3 times CD. So instead of BD here, I'm gonna write AB square equal to AD square plus 3 times CD, the whole square. See, instead of BD, I'm writing 3 times CD. So the square is not applied. See, square is outside of BD. So instead of BD, I'm writing 3 times CD. And since square is there, so I'm writing the whole square. So AB square equal to AD square plus, if I open the bracket, it will become 3 square and it will become something like this, 3 square and CD square. AD square plus 3 3 is 9 CD square. So let's keep this as equation number 2. Okay, so that's equation 1 and equation 2. Now let's go to the proof part. The proof. 2 times AB square equal to 2 AC square plus BC square. And then we'll just use whatever we can from here. Okay, let's keep this on the side so we can see what we can use. So let's do LHS first. LHS 2 AB square, right? So we have AB here, so we can use this. So 2 times, instead of AB, I can write AD square plus 9 CD square. So if I open the bracket, you can write from equation number 2 AD square plus, see, bracket this 2 will multiply both, right? So 2 times AD square is 2 AD square and 2 times 9 is 18 CD square. So can we do anything, or is it this? No, right? It's completely different. So let's just keep it as it is. Now let's take RHS and see what we can do, because AD is here and then CD is this. We cannot do much from this. Okay, so let's take RHS. See, we can also replace AD by this and lambda to recta. Like, it becomes a little complicated. That's why, like, we can do something about it, and we can actually replace AD and then go on and then come out to be this also. We can actually do that. So in case you want to do like that, you can try it on your own. Okay, but it's a little complicated, so I'm just stopping here and then I'm taking RHS and try to match it up. Okay, 2 AC square plus BC square. So 2 times AC we got this. So instead of AC, I'm gonna put that. Okay, instead of AC, I'm gonna put 2 times AD square plus CD square plus BC. If you look at the diagram carefully, BC is this, right? The whole thing, which is BD plus CD. So instead of BC, can I write BD plus CD the whole square? Because it's BC square, right? Square is outside. BC square. So instead of BC, I replace BD plus CD, because BD plus CD is BC. Now if I open this bracket, 2 times AD square will come out, 2 plus 2 times CD square will come out, plus, instead of BD, I've already told you, because they gave us this in the given, so instead of BD or DB, same thing, we have to write 3 times CD whenever you see BD. So instead of this BD, I'm going to write 3 times CD plus CD square. So 2 times AD square plus, oh, by the way, we replaced AC square with this because it was from equation 1. Okay, don't get confused. Now 2 times CD square plus 3 plus 1 is 4 CD square. So if you open the bracket, this 4 is being squared, so it will become 16 if you bracket for power, and then CD square. 2 times AD square plus 16 plus 2 is 18 CD square. So from here and here we can say that therefore LHS equal to RHS. Like I've told you, we can do this not just in one way but several other ways also. Okay, it's just not like you take one. See, for example, let me show you. Okay, if I do this, okay, 2 times AD square plus 18 CD square. After this, I could have replaced AD by 2 times AC square minus CD square plus 18 CD square. Okay, and then 2 times AC square minus 2 times CD square plus 18 CD square, 2 AC square plus 16 CD square. Now na AC to IGs na ito na. So BC like ito mo. So I can do, instead of BC, see, we know that BC, let me do this in rough section. This is rough, okay. BC equal to BD plus CD as well. Na. Arrow BD is 3 times CD, so 3 times CD or CD, so it's 4 CD. So BC can be written as 4 CD also. So if I do 2 AC square plus 16 is outside the bracket, outside the square. This square CD square, this square only applies to CD. So if I want to apply the whole, or if I want to make it a whole bracket, it will become like this, because if I open the bracket now, it will become 4 square CD square, and 4 square will become 16 square, 16 and then CD square, right? So instead of 16 CD, I can write 4 CD. So 2 AC square plus, instead of 4 CD, I can write BC, which is the right hand side. So you can do it like this also from here, continuing without taking RHS. So you can either do like that, or you can directly go to RHS also. It doesn't matter. Whatever is simpler for you, I think it will be best if you do that. So I'm giving you 2 options here. One is to take RHS in case the other option is complicated, but this method is complicated but less kata wala ito. Itu complicated wala se. Got it? So if you want to write this down, and then the other method also I'll show you. And now for this other method, you will have to write reasons from equation 1. See, equation 1 I changed, okay, AD, because I needed to replace AD ito orne CD to ito fale potay na minus coefficient, and then this will be the reason for changing here. Ito la reason ulit. This reason is this, so equal to, we're talking about LHS here na, equal to RHS. You can do that also. So you can either do this or the other one, and don't forget to put equal to signs over here also. I completely forgot. RHS equal to RHS equal to. So that's it.